So this is section 10.1. We'll do the whole section in an entire day. And so this is the beginning of our new unit, and our new unit has to deal with working with conic sections. So there are conic sections. Conic sections are taken as you look at a cone and then an inverted cone, and you start cutting through it with plane sections. In other words, flat sections. So there's actually 7 conic sections, and what we're seeing right now are the 4 that we're most familiar with. So if we cut the cone parallel to the base, so horizontally in this picture, so it would be this one, then that becomes a circle. So let me see if I can capture that. And so I've just paused that for a second. So that's a circle when we cut this conic section parallel to the base. It only cuts through one of the 2 cones. The next one, if we cut at an angle that is not steep enough to catch the other cone, so in this case, this angle is, the slope of this is less than the slope of the edges of the cones. So we only cut through one of the 2 cones. Then we get this elongated circle, or in other words, this ellipse. And then as we continue to cut it and make that plane more vertical, if we make the plane exactly parallel to the axis, and the axis goes through, the axis is vertical in this picture, it goes through the tip of the cones. So if we cut it parallel to the axis, then it cuts through both cones, the regular and the inverted, and we get 2 sections, and that's called a hyperbola. And then the last conic section that you're familiar with is if we cut this exactly parallel to the edge of the cone. So I'm going along the edge of the cones here with my pointer, and this plane is parallel to that. It'll only, again, intersect one of the 2 cones, and that gives us our parabola. So those are the 4 conic sections that we're familiar with. And we'll get into why there's a total of 7 in just a second. So here's the 4 conic sections, just a quick sketch here. So if you get those sketches into your notes, that would be good. And here are the 3, we call these degenerate sections because they don't make a conic shape like above. They make shapes that we're familiar with that we don't think of as conic sections. For instance, if we take a plane and intersect the vertex of the cones exactly, then all we're going to get is a point. And if we take a plane and run it right along the edge of the cone and the inverted cone, then we're going to only contact those 2 cones in a line. And then if we could do that on both edges of the cone and inverted cones, and then that gives us an absolute value of x function. So these 3 are considered conics, but they're considered degenerate conics because they don't make these curved shapes that we're familiar with. We have a conic app on your calculator. It's under the app key. So if we look at our calculator, go into the app program, and we hit section 4 or option 4 conic, we can look at the 4 conics. And I'm going to look at the circle here, and you can see that the circle has a standard and a what we call a vertex form. And so I'm just typing in 2, 3, and 5 for the center and the radius of the circle. And then if I hit graph, then it shows me a graph of the circle. And I can also hit my trace key, and it starts over there on the right side of the circle. And the center is 2, 3, but the hash marks don't exactly line up with that, which is okay. But I can trace around the perimeter of that circle if I wanted to. And so we notice here, when we go into the menu initially, we have this option 1 here is called the vertex form, and this option 2 is called the standard form of the circle. And so we need to be familiar with both of those expressions of the conic section for the circle. If you've got an SE that you're working with, like a color calculator, then you can arrow over here and change the color if you'd like to. So that's how we're going to identify circles, either by vertex or by standard form. We'll get into the characteristics in just a little bit. Here's how to use your conic app for the next conic section, which is an ellipse. And again, we have, in this case, we have a wide ellipse and a tall ellipse. So they're both vertex form. We don't have a standard form option. So we would have to get the formula into vertex form in order to graph it on our calculator. So we're going to go to option 2 here, ellipse. And again, we're going to use, we'll plug in the H and K and the A and the B. So I'm going to put an A in of 4, looks like a B, I'll put in 3, an H, 2, and a K of 3. So that's going to give me a 16 and a 9 on the bottom. So this is going to be a wide ellipse because the bigger number was underneath the X expression. And again, we can trace. So we're over here on the right side of the ellipse. And if we hit the trace button and our arrow button, we can go ahead and with that trace and using the arrow keys, we can trace. I'm trying to get at the trace here. We can go ahead and trace around the perimeter of that ellipse as well. So I just don't think I'm getting it to work all that well here. Let me just try to forward the video a little bit and see what happens here. There we go. So now I can hit the trace, and starting at 6, 0 on the right side of the ellipse. And I think my video is cutting out. It's not doing the trace part of the video. So, but if we hit this key here, then it will go ahead and trace that conic. The video is just not working real well. Okay, so the next conic section is a parabola, and again we have 2 vertex forms of the parabola. One is going to give us a sideways parabola, and the other one is going to give us the up-down parabola. And so I'm going to go into my app again and pick my conics, my option 4. And in this case, it's option 4. And so I have to give a p-value in this case. So I'm gonna do a sideways parabola. So I'll do an H and a K. So 2 for my H, and I think a 3 for my K, and then my P I'm going to make it 0.25. So when I multiply it by 4, that whole thing in front of the X becomes a 1. And so when I graph this, then the vertex of that parabola is going to be at that center 2, 3, the HK location, and I can trace to trace along that parabola. And I'm going to go back and hit quit, and I'm going to put in a different P. So in this case, I'm going to put in a P of 4. So now there's a 16 out front. And if you know a 16 out front, then it changes the scale. These values are much larger, so it widens out that parabola quite a bit. The last conic then we can use our calculator for is a hyperbola, and again these are 2 vertex forms. One is for a sideways hyperbola, the other one is for an up and down hyperbola. And so I'm going to go back into my apps, my conic app here, option 4, pick option 3 for hyperbola, and then I'm going to do the sideways hyperbola. And so the sideways hyperbola, then you got to make sure the appropriate signs are there, and we'll talk about that in a minute. I just kept the same values, so there's my sideways hyperbola, and then I can again trace along that hyperbola if I want to. So it's just a quick information as to how to use your graphing calculator to look at those shapes. So let's take a look at the characteristics of the conics. In other words, how can I just look at these expressions and know what they are? So for instance, we want to focus in the x squared and the y squared. So this would give us an x squared if we FOILed it out. This would give us a y squared if we FOILed it out. In the standard form, we see we have an x squared and a y squared. So we got both the x squared and the y squared present. And they're both positive. So it's positive x squared, positive y squared. When I FOIL these out, again, they would both be positive. And then we have equal coefficients. So in other words, there's a 1 here and a 1 here, or a 1 here and a 1 here. They don't have to be 1. They could all be 4s or something like that, but the coefficients are equal. And so all those characteristics are telling us then that this conic is a circle. So I think you can really see it here with the center 2, 3, and the radius of 4. So we're looking for an x squared and a y squared, same coefficients, both positive. Really, anything else other than the squared terms is pretty irrelevant. Just a quick note though, a circle could also look like this. It kind of looks like an ellipse, but these are the same value, so we could multiply through by 16 and get this expression up here. So we could also look, if they do have denominators, we could also verify that with equal denominators, it would still be a circle. Let's take a look at these two. So we're going to go through that protocol again. I got both an x squared and a y squared, but now, and they are both positive. There's only one time when one's negative, and that's not this conic. It's something else. But if you notice either the denominators or the coefficients, when you look at them, they're unequal. And which means I can't multiply through by a 16 or a 9 in clear fractions. I would have to multiply through by like, I don't know, whatever 16 times 9 is. So since those denominators are unequal, this conic has got to be an ellipse. And so we know that that's an ellipse, and really we're keying in on these unequal denominators and unequal coefficients. Then if you look at these expressions, the first thing we're going to notice is that only one is squared. So this x is squared, but the y is not. And if we FOIL this out, this y would be squared and this x would be not. So already we know that this is going to be some sort of parabola, because we're missing a squared on both terms. And it doesn't matter if we look at the x term and the y term, they could be positive or negative. It just inverts the conic. So it's either going to make it an up-down, or an up or a down, or a left or a right. So the signs in front of the x's and the y's don't matter. And denominators and coefficients could be equal or unequal depending upon that value of p. So that's irrelevant as well. So we're really only cluing in on whether or not the squareds are present. And in this case, the squareds are not present for both of them. So this conic is definitely a parabola. And again, we're keying in on the fact that we have a y squared and an x is not squared. Or in this case, an x is squared and a y is not squared. Okay, so looking at these two then, we're going to key in on this. So we're going to acknowledge that we have an x squared and a y squared, and we have one of them being negative. So in this case, the y squared's negative. Same here. In this case, the y squared's negative. And we're looking at denominators here, and they could be equal or unequal. It doesn't matter. Even if they're equal, this minus sign between them is going to take precedence. So we definitely know that this is hyperbola because of that minus sign. And because both terms are squared, so that's definitely going to make it a hyperbola. So at this point, you should be able to identify the 7 conic sections. So the ones that we're familiar with are circles, ellipses, parabolas, and hyperbolas. But we also have to be looking at the degenerates, the point, the line, and the absolute value of x. And then so we should be able to look at expressions for conics and be able to pick which conic we're looking at out of these 7. So at this point, you should be able to do the Unit 1 homework for Chapter 10. And that's in Libsyn.